Okay, welcome back again to another one of these problem-solving grade 9 unlocking questions that we're going to go through. Another question from 2022, again paper 1, where a lot of people didn't do too well. The first part was okay, so we'll get through that pretty quickly, but part B is a little more interesting and there were some mistakes made. I will show you the two main areas where people made mistakes, which prevented them getting the full marks. So, first of all, we have a sphere and a cone, and they're solid. They give us the volume of a sphere and a cone, so these aren't equations you need to remember. The volume of the sphere is equal to the volume of the cone, so you need to find the ratio of R to H. And honestly, this is pretty quick. So you know the volumes are equal, so all we're going to do is we're going to write the volume of the sphere, which is 4 over 3 pi r cubed. We can't sub anything in because we don't know the radius. And it's going to be equal to a third, and again pi r squared h, because again we don't know the values. Now the important thing here is that the radii are the same. So it does tell us, because they're both r, they must be the same. And that's why in your diagrams you should actually be very careful. This is more for something maybe to do with A-level maths or physics, things like that. But if you label something the same letter, it means you're implying they're the same, which isn't always the case in your problem-solving questions. So just be really sure that when you label them, they are actually the same. This also comes up in algebraic proof. When people say two different numbers, some of you will write 2n and 2n plus 1. That doesn't really imply they're completely different. Anyways, and from simplifying, we can divide both sides by pi. We could times both sides by 3. And we could also divide both sides by r squared. And that leaves me with 4r is equal to h. Now, here's the bit where people get very confused, is this thing r to h. Remember, the number on the left will tell you how many times bigger h is than r. So hypothetically, if I had 2 to 1, that means h is twice as big as r. Because for every 2 that we have under the r, we have 1 for h. So r is 2 times bigger than h. Okay, so just read it one more time. R is 2 times bigger than h, because for every 2 units that r has, h has 1. So in this case, what is this equation telling me? So many students write this, which is wrong. This is telling me that r is 4 times bigger than h, but if I read this equation, what's it telling me? It's telling me that h is 4 times bigger than r. So the actual answer is 1 to 4, because h is 4 times bigger than r. h is equal to 4r, right? If I wanted to, I could write it like this as well. So just because the equal sign is the other way around, doesn't mean any different. You need to read it very carefully. 2 marks, pretty okay. I know the cancelling can be a bit confusing for some people, but let's get on to part B. Ooh, how exciting. A different sphere and a different cone. The reason why they put that here is because some students, rightly so, tried to use this ratio in a question that was similar to that before. So they'll try and use the ratio of 1 to 4 to solve this. That is genuinely confusing. That's not your fault if you did do something like that. But now they've told you they're different spheres and cones, which means R is different in this question than it was in the previous one. Anyway, the surface area is equal of the sphere is equal to the surface area of the cone, and they highlight the word total for another reason that came out about 10 years ago with surface areas of cones. And it says find R to H, and you're going to have a surd. Okay. So first of all, surface area of a sphere is just 4 pi r squared, nice and easy. Now, the surface area of a cone is a bit different, a little bit different, because it's pi rl. Okay, that doesn't sound too different. What are you talking about? Well, that's not the total surface area. If you imagine a cone in front of you right now, it will actually have a flat circular part on the bottom. So this is also an area. And what's that the area of? It's the area of a circle, so it's pi r squared. Okay, so what can I do first? I can still eliminate pi. Cool. So 4r squared equals rl plus r squared. So I'm going to minus r squared from both sides. We have 3r squared equals rl. I'm going to divide both sides by r now. This is really good. And we get 3r equals l. Now, The problem here is they want the ratio of R to H. I've got here the ratio of R to L, which would be, in this case, R is smaller than this, L is 3 times R. But that's not the answer, because it's not asked me for R to L, it's asked me for R to H. Okay. If I go back, H is the vertical height of this cone. It's the vertical height. So, if I look at this, that would be a line that goes vertically through the cone like this. If I extract that quickly, let's call that H, that L, and that R. I need to eliminate L from this expression because I don't care about L. I care about R and H. So I need to introduce H into this equation and get rid of L. So how can I do that knowing this? Well, Pythagoras. H squared plus R squared equals L squared. So instead of L squared, I'm going to write H squared plus R squared. That part a lot of students missed out on. The first part they missed out on was including the pi r squared from the circle. But this right here, a lot of students got to here and thought, hang on, I don't have a H. What do I do? Which is valid, but you cannot live in fear. Anyways, you can't live in fear, you have to just do it, right? So what we're going to do is we're going to sub in this value for L. Actually, we're going to have to square root both sides. H squared plus R squared equals L. Now I can sub it in. So we have 3R equals... Now I know what you're probably thinking. That looks incredibly difficult to solve. And it is. Well, not solve, but get into the relationship. So what I'm going to do is I'm actually going to square both sides. So the left-hand side becomes 9R squared. And that gets rid of the third. So why did I do that? I squared both sides to get rid of the third because I can see that I can move the r squared over to the other side. I can now minus r squared from both sides. 8r squared equals h squared in order to simplify my expression. Okay, so another kind of tip that I give a lot of students is when you see something you don't like, see if you can get rid of it. Normally this is fractions, right? Like if you have an equation that has a fraction in it, they don't like the fractions, why not get rid of it? Just follow the rules of maths. There's nothing saying I can't square both sides because I've done it to both sides of the equation. That's the key thing. But now, again, it doesn't say r squared to h squared, it says r to h. So now I'm going to square root both sides and we get square root 8 r equals h. So then what's the ratio of r to h? Well, h is square root 8 times bigger than r, which if you look, it's a square root of n. So in this case, n is just equal to 8. Not the easiest question in the world. It seems easy from here, but then it gets a little bit tricky, and obviously the rearranging's not the easiest thing in the world either. But hopefully that makes a bit more sense now. So again, the two kind of key takeaways. One is if you have a part in your equation that you really don't like if there's a third, or if there is a square, or if there's a fraction, you can get rid of it as long as you follow the rules of maths. What you do to one side, you have to do to the other. You also can only do it if there's an equal sign. Someone was asking me before, if I have something like this, it wasn't exactly this, can I square it in order to make my equation this? Sorry, it's not an equation. Can I make this as an identity? No, because I didn't square both sides because there's no equal sign. So I can't do that, okay? Keep that in mind. But hopefully that makes a bit more sense in terms of the problem solving, in terms of how you can approach this, and I'll see you in the next one.